My name is Michael Burch. I'm actually be running through a handful of different vulnerabilities and showing how they work and then talking about the solution. I'm actually going to be leveraging our platform here at Security Journey to do so. In this short series, I'm going to cover the OWASP top 10, and we're just going to have a casual conversation and dig into each one of these vulnerabilities. So to start with, let me share my screen. What I'm showing you right now is our sandbox exercises. And what we do is we take you through a web application and we're going to show you how an exploit works. So for this one, we're dealing with SQL injections. Now, this is CWE 89. And what it really involves is when we improperly handle statements from our code that are reaching out to a database in the SQL language, and we're making queries. That's what the Q stands for, is query, and trying to pull data back, or we're trying to update data, or we're interacting with that database one way or another. There's some improper ways to do this can open us up to some big vulnerabilities, and that's what we're going to look at in this video. So the first we're looking here, I have an online fitness mall application. And we're going to go through the reconnaissance phase. And starts us out with, we need to select a store. So let's check out Jill's Outdoor Store. And we need to add a product to our shopping cart. So let's add this really cool $80 backpack. Awesome. Now, one thing it says here is there's a way to apply a coupon code, and this is where the hint says that it probably involves an SQL injection attack type vulnerability. So let's test it out. First thing it says is to test out a special character, see what type of response we get. Let's just try the normal first. So if I just put test as a coupon, what's it say back? Invalid coupon code test. All right, well, let's try to interrogate it a little bit, and that's where I'm going to add just this single quote character and see what it does. Internal error occurred. Well, that's not like the last error I got. So whenever we get a different response from a system, that's something worth us digging into more. When we can cause the system to act in a way that we think maybe it wasn't designed to, there's a chance there's a vulnerability there. So now let's play around with it. Now, the next thing we're going to talk about here is why does this happen, right? So when we create statements that are reaching out to the database, we use terms like, hey, we want to select everything from the coupons table where the code equals the word code. Well, that's interesting. I would like to see that. I would like to apply any code I possibly could if this happens to reach out to that coupon database and I can actually manipulate it. What the end state of that looks like, if we can manipulate it to look something more like this, we can then now get the final statement in the code to actually look like this. And this would be the final statement that's saved and sent up. How would we do that? So there's a traditional way that we do some attacks. And in this specific example, what we're going to do is we're assuming that says, hey, select all from the coupons where the code equals A, right? We're going to replace this part of it with what we want to say. And then we're going to say, or X equals X. Now, the nice part about that statement is that's always going to be true, right? So we should be able to get that to work, because if the statement takes this, it's basically say it's true no matter what. So we should be able to get maybe the first coupon that's in that database. So let's apply that coupon and see what happens. We got it. We got the Summer Love 10 coupon applied, and I just saved $10 on my order. I don't want to stop there. I'd like to even do more if I can. Like, saving $10 is cool, but let's see how much farther we can take this. So in here, we have a new type of statement. We do the same A, but this time our OR says 1 equals 1, which will be always true. And then we want to order the list by the discounts descending. This last little statement here, you leave a space between, says ignore everything else after this, right? It's the way to kind of cut off the rest of the statement. So no matter what was used up here to try to end our statement or add on or everything else, we can kind of ignore it and just execute what we want to execute. So let's see what happens when we do that. Well, look at that. I got a $1,000 coupon applied. Well, since my product only cost me $80, I really hope this will give me a $920 refund for this transaction. So let's talk about the defense of this. And what we're going to do is we're going to jump over to our code editor and actually look at the code. Now, you could solve this in a lot of different languages. And actually, one of the cool parts here is if you come to the top of our lesson, we actually have it even in C. So we can actually go look how this was implemented in C code. A little more complex, something you wouldn't expect. But nice little thing is we actually have an article where we can actually talk to you by, thank you, Tyler Cooper, for telling me how to write prepared statements in C. I don't personally write code in C, so what I'm going to do is I'm going to jump out and I'm going to solve this exercise in Python, something I'm a little more comfortable with. Let's see if I can see the vulnerability right off the way. Well, right here, looks like we have a select statement for a database trying to get the code discount from where the code equals the coupon. Well, this is called string concatenation. We're allowing the user without any validation. So that's the first part, not doing input validation. But second, we're immediately concatenating the string. So it puts whatever string they put in there and it reads that as raw data. One of the ways that we can combat that is through something called parameterization, which it looks like we have an example of that here. So maybe if I just take this and I replace it, let's see if I fixed it. Right? Let's save and run the code. So it went through, my code compiled, but I broke functionality. All right, let's see what happened. Well, I guess it makes sense that I can't just input the example. That's not the actual solution. That is an example of what the solution looks like. Right off the bat, we can tell some big differences. It has c.execute. Well, I probably want this to be cursor, not c, because that's how I have my variable defined above. And then I probably want to keep all the rest of my statement the same. So, but this time I want to add parameters. So look here, we can actually use this character here, right, the %s, as a placeholder for the variable I want to pass in. And then I can put the variable in here, and that's called parameterization. What that does is that it abstracts that data away, and it's going to get past the back end without being executed. So it passes an additional parameter. That's one of the ways that we can actually prevent this vulnerability. So let's try that out. Let's delete the code from my example here, and let's do our equals, and we'll do the % and the s. And this time, we'll pass in a second item, which will be our coupon code as a parameter rather than trying to send it in as just a direct string concatenation, which leads to this vulnerability. Let's save and run our code, and let's see if it works this time. Awesome. My code compiled. I didn't break functionality, and we were able to prevent that vulnerability. Now, let's go play. Let's go see if I'm able to still do what I did before. So before we did a test for our error, which should give us back an invalid coupon code. And in this example, the original starting way we tried to do that is we just did a equals x over x. Last time, this put that first coupon on. This time it won't allow us to do it. It says it's an invalid coupon code, so it won't even take it, and we're getting the proper error message. And even if we try to put the old one back, it won't accept it. It's now catching that as a not proper coupon code because we've been able to extract away and prevent that string concatenation. So not only have we been able to solve our solution, we've been able to go back in our application and see that it had the effect that we wanted it to have. So that's my end of my video. Quick little introduction to SQL Injection, how you can kind of dig in, see where those are at, things to look for. Whenever you see string concatenation, that should be a very big red flag that you should be doing something different. Security techniques are parameterization, as well as you should really be doing some input validation to make sure this coupon code coming in follows the rules of any type of coupon code you want to use before you actually leverage it in the rest of your code.